Hello everyone, this is Ray Long, and welcome to another episode of Full Stack Distributed Systems. Alright, last time we left off, we had just basically finished our first iteration of our dice roller, and I'm pretty happy with it. I think we've got a nice basic dice roller to work with. We can hit roll the dice, it increments. Let's go through a quick demo just to recap. Let's make sure we're engaged here in the mobile command unit. Mobile command unit engaged, locked into this totally comfortable chair, which is just a metal folding chair. That's how ascetic I am in my wizardly ways. Alright. I like to keep it a bit uncomfortable. Keeps me focused. I know it's a bit masochistic, but what are you going to do? Right, it's taking a while to compile again. Oh yeah, it always does that the first time. Here we go. Scene is live. Roll the dice. We got a 2. Bam. Alright. Let's go to the dice roller and let's just hypothetically say we had 20-sided dice. Now, will it work? Oh, we've got a 10, 16, 10, 11, 14, 2, 5, 1. Yeah, it seems to be working. So, now we might want to consider whether or not we want to use seed values in our random number generator. So, the thing with Unity's random number generator is that it is not truly random. It's a pseudo-random number generator. Okay? And the point at which that sequence begins is called the seed. Right, so if we think about exposing a seed value or a field that we can modify to represent the seed, then we can control our random number generator and at least get predictable values in a predictable sequence. It's kind of interesting. And goes to show you just how pseudo-random it actually is. Alright, so how are we going to do this? Well, we're definitely going to want to expose, in our dice roller script, we're going to want to expose another field, and then we'll need to refactor accordingly. Okay, so why don't we switch over to Visual Studio and go here, and we'll call this public int seed, and we'll say we'll start at 666 just for fun, just to freak out the normies, man. All right, need some goddamn caffeine. Just a second, please. Oh, delicious. Okay. So it's startup. Where's our startup method? We want Unity engine.random seed to equal seed. Random.state. Let's see. Whenever I get an obsolete message, I like to investigate and see if I can make it work. Okay. And I don't know how this is defined. Let's go see. Well, how is state defined? Public struct state. Oh boy. I'm not seeing anything here. State. Okay. Seed. You know what? We're going to use seed because documentation says seed. So it may be obsolete right now, or at least it may be. But you know what? We're going to have to go with that for right now. We'll figure out a solution after we do a little more investigation. Seed. You know what? We want to update the seed. Let's just pull this out into its own helper function because let's see. We have it selected. Let's right click. We can go down to there should be why won't it let me refactor and extract that? That's weird. You know what? Just suppress. Yeah, great. I'm glad. So why don't we go over here and call this update seed. We need to make this method. It is private. We will use the .NET convention of using private methods, prefixing them with an underscore and a lowercase letter. That's the .NET World Convention for private methods, private fields, stuff like that. You don't see it too often in the Unity world, but I like it, so that's what I'm going to do. Okay. Fantastic. This doesn't have to be all the way down there. I like to make things nice and consistent. There is a way to format the code. Oh, I forget. Well, it doesn't matter. So now if we go back over to our Unity environment, we will see after we update that we should have a seed somewhere. Where's that seed value? Oh, there we go. See? It shows up as 666. Very good. Let's try to run this. Okay, we have 5, 2, 2, 4. See if it does the same thing again. 5, 2, 2, 4, right? So that's what the power of the seed does, okay? It allows you to get a predictable sequence of pseudo-randomly generated numbers. Randomly generated numbers. It's hard to say, but that's basically the point. Like the seed allows you to control how this is going to work, how the number generator is going to work, the values that you're going to get back. The seed makes it predictable, okay? Which is good from an auditing and compliance perspective. I used to work in regulated gaming, and the people who audited the code and the games to make sure that they weren't illegal, to make sure they passed all compliance, like all regulatory, all regulations and complied to everything, and make sure it wasn't ripping people off illegally. They definitely preferred pseudo-random number generators that they could cycle through and predict and see the whole range of values to ensure that there was enough diversity. So, and one technique that you can use is you can have two random number generators, one from the system, and this one that we've implemented here or tapped into here, and you can use the system random number generator to generate your seed value, and you can have that seed value drive the other random number generators that you use. So, it's all pretty straightforward. It's all good stuff. Okay. Let's go back to Visual Studio and see if there are any refactorings that we need to do. Whale update, we want to update the seed. This will allow us to gain a little more flexibility when we run our DiceRoller. So let's give it a shot. Alright, so we should get 5224, right? Oh, you see what it does? So if you put this here, it resets the seed. I bet you, the seed gets incremented along with the, I bet it's more like an iterator or an index, like an iterator. That'd be interesting. So we don't want to reset that every time like that. That'd be incorrect behavior. Very incorrect behavior. Let's move this back over where it belongs. You know what? Let's call update the seed right here like this. You know why? Because we can expose this to a button in our UI for debugging purposes. We can do the same thing. We can make a button. You guys weren't looking at Visual Studio or what? No, I guess not. So let me pop over and show you what I just did while I'm thinking out loud. I'm trying to be super conscientious of making sure that my wonderful viewers are looking at the same screen that I'm looking at. That seems to be a pretty important requirement to make this a halfway enjoyable show. Alright. So we can see that I've decided to make this a public method, which I'll do right now. And this means we're going to be able to call it from the UI if we want to, in order to update the seed and start the number generator again. So, why don't we go into Unity and build that button right now? Okay. So, let's do a couple of things. Let's call this the roll button. Clear this log. Okay. I want to copy it. I want to paste it. I want to rename it. You just call it seed button. I'm going to be super original here. Alright? Seed button. let's update the text to say something different. We'll say set the okay. And now we probably want to move this. Yeah, that's fine. And I'll call this, well, we don't have to do anything with that. So the seed button, we can call it click. Set update seed. And that's it. And let's run it. One moment. Okay, now if we roll the dice, we should get our 5224. Amazing. Now if we set the seed again, we should get 5 next. See how it reset it back to the point in time. Let's go to the DiceRoller. We want to update the seed to 12. Alright, so let's set the seed. And we could do this however many hundreds of times it would take to get to 666. You know, 600 and, well, 48, 58, whatever. I'm not good at math right now, ladies and gentlemen. But we could also just go back here to the seed, set this back to 666 like we started with, set the seed, and then roll the dice. So that's what we've done. This is good to commit. An error occurred. Hogwash. There's no error. Alright, whatever. Gonna find my cloud stuff. If the services come up, then, you know, you can see the asset store. Oh, man. Oh, now we can collaborate. Oh, isn't that wonderful? So we're implementing seed-based pseudo-random number generation. Okay. This is pretty good. What are we going to do with this next? Well, we should probably, let's make sure we can see. All right. We should probably update the prefab, right? Totally. So why don't we just go on here? Yeah, that looks about right. All right. What are we going to call this? We can bring this down here. Yeah. And then we could have, we could try to do this. Yeah, okay. Like I said, some things just need to be coupled. What's the event system? Okay, that's probably for the UI stuff. That's good. Okay, fair enough. But now we have this dice roller, and we can use it to roll multiple-sided dice to our heart's content. But there are some things here that we haven't implemented yet. We haven't implemented our to-dos to calculate our target values and to determine success or failure. And we haven't determined if we're going to do any reroll values, right? So let's start thinking about how that logic is going to work here for a moment. Let's go over to the code. This is where we want to do our check, right? Because this is where we are encapsulating our dice rolling logic. So if result is less than target value, no, we don't want to expose bools as public fields. It's such a bad idea. I mean, exposing these is really a bad idea on so many other levels, but what we should do here is we should subscribe to a successful dice roll event. Or no, excuse me. Publish to or invoke a successful dice roll event. There we go. We want to trigger an event, right? For now, we will just log it. Let's see. Let's add results. Target equals target value, right? Otherwise, we're going to want to invoke a failed dice roll event, and for now we will log this, right? We can just copy and paste this. We don't have to, we're not barbarians, you know. All right. Fantastic. And now we can cross off this to do. Let's set a target value. Okay. So basically we are providing sane defaults for, oh, excuse me, sane defaults rolling 1d6. Okay. Why don't we go back over to Unity? Didn't I get the message? What's going on? Hey. Okay. Oh, it's from the... I see. Okay. Let's do this. This is the prefab. I think it's because it was linked to the prefab, you know? So, roll the dice. Success. No. Our logic is bad, obviously. If result... do greater than or equal to the target value. Yeah, let's rephrase that. We want to match or beat. We don't want to come in under. Some games you want to come in under. I think for this game that we're modeling here, as the default setting, we'll model it as meeting or exceeding scores. So like if somebody had, like maybe they had an armor of 1 and you had to roll a d6, it should be pretty easy to beat. It should be harder to beat them if they have a 6 that you need to match, right? Because you have a 1 in 6 chance of, you see the math, right? Obviously, some rolls are going to be easier than others to make. And we can accommodate that by having these fields exposed to calibrate our dice roller. So let's roll the dice. Failure. Oh man. Our result was a 5, our target was a 6. What are we going to do, That's just the way fucking dice gods go. Oh, this is going to fail. Fail. Okay. Okay, 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 okay. So now, think about this. When are we going to get to a 6, right? We have a lot of 5s and 4s and 3s and 2s. So, knowing this about the seed, knowing that if we start at position 666 on our particular random number generator, we're not going to see 6s for a while. I didn't see any... Like, maybe I can try to find in here. No. It's not happening. I need some better logging. Maybe we can hook into these logs somehow. But I don't remember any one success. So that means we can calibrate our random number generator, and we can plot out the ups and the downs, right? Let's say we were to take the sequence of 5s, 2s, 2s, 4s, 3s, 2s, 5s, 4, 6, 4, 2, 1, 1, 2. And you just plotted that out on a graph, you could kind of start to see like a roller coaster effect, right? And if you're really savvy, if you're really smart, you could try to graph out a bunch of different roller coasters from a bunch of different seed values to figure out the optimal play experiences, right? Now imagine you're doing slot machines and you're doing gambling and you want to say, hey, you know what? What is a slot machine? Really, what's the core mechanic of a slot machine or a video slot machine or, what is it? It's a loss disguised as a win. That's right. That's the dirty secret. A loss disguised as a win. Really? You put in $1 and you won 25 cents? Wow, that feels good though, doesn't it? It feels good when the heart starts beating because you won 25 cents and the house is eating up 75% of your bet, But you can usually calibrate those machines to have a payout percentage, right? Like, I've seen a lot of 98% payout machines, right? Like, basically the machine is guaranteed. If you play it enough times, if enough people play it enough times, the machine will pay out 98% of what it takes in, and 2% will be kept for the house, which is, considering all the cash is flowing in and out of those machines, is not a bad position to be in. So, anyway, that's basically how the seeded random number generators work. And yeah, it's pretty powerful when you start thinking about, well, if I want to do procedurally generated effects in my game, it's good to be able to control the mutation, right? It's good to be able to start out where you need to start out. And using those pseudo-random number generators are a wonderful, wonderful thing. Okay. Let's go ahead and you're probably not going to be able to see this inside of the video, but I'm going to go ahead and hit this collab button up here. I'm going to put in just more work on the DiceRoller. Let's publish that. Okay. Let's go back to our project. I think we've spent enough time on dice rolling for now. I don't know about y'all, but I'm kind of sick of looking at the dice roller for now. And we can just kind of put that away. And that'll be fine. But before we do that, let's just be diligent and update our dice roller prefab. Right? Very good. And let's just make sure our canvas prefab is updated. Fantastic. Now we can save it. And we'll just update this again. Updating prefabs with sane defaults. That's my commit message. Okay, so we have a pretty good dice package now. A good dice package. I love my bad dice. Oh man, I was thinking about like the social justice warrior dice. Like he was over there with the patriarchy, but he's over here with the Zimzers. Oh yeah, that bad dice is going right into the goddamn video. Because now we are working on characters. You see how it all unfolds? Plans within plans within plans. Alright, so we're going to do character. Oh, what are we going to do with our character, huh? We've got some options. We have a few options. We have a few things to consider. We have to consider how our characters are going to be used in our game engine. And if we're going to make this into a distributed system, we have to consider how they're going to be shared over the network. No small, easy task to consider, right? I mean, it's no small, easy thing to consider. I mean, we'll be able to use the Unity, the inbuilt Unity networking engine. You know, networking is hard if you're trying to maintain mutable state, and that's kind of exactly what we're going to be doing. But there are things you can do, like server-side checks and verifications, you know, to make sure that the client side is not cheating and sending you data that's, you know, well, cheating, you know, allowing the cheater to gain unfair advantage. You know, you want to sanitize things on the client side and on the server side, and we kind of want to make our code as simple as possible so that when it comes time to distribute it across seemingly, hopefully, millions of clients, we want to make sure that our servers aren't going to buckle and break and start throwing null pointer exceptions everywhere or be exploitable to abusive state changes, you know? You just heard me drinking. That was my latte because I need the caffeine. That's right. Gotta have the caffeine. So let's start thinking about the character. Well, we're going to need some kind of C# script, aren't we? Let's start with an interface again. I like it. Why do we call this an IBaseCharacter? Because maybe we have characters that the player can control. Maybe we have characters that only the AI or the computer can um, see, you know? So we got to reload Visual Studio because we got a new folder. But sure, whatever. The line endings are a pain in the ass, so just make a choice and stick with it. So OBS showing you. Let's go over to Visual Studio. Okay, now it's reloaded. We have our IBaseCharacter. Well, again, we don't want to pollute namespaces, right? So why don't we go ahead and get this out of the global namespace. We'll call this character. Alright, there we go. Fantastic. We're going to make this an interface. Okay, and just like I said before, interface have prototypes. They don't have they have declarations. They don't have bodies. So all right. So what's our base character going to need? Well, we might be tempted to add a name, but if we hop back over to Unity for a second, we will see that objects have names, right? Like this is DiceRoller. That's the thing's name. Its name is DiceRoller. This is called main camera. We can find it by its name. So we don't really need to add necessarily a name field to our game object. But we have to think of if we want to tightly couple that to its representation under the hood and on the screen. So for now, we'll just leave off name. But what other things might be interesting to know about our base character? Well, we probably need. Let's just make sure that we go back to Visual Studio. We're probably going to need a starting position, right? And typically those are transforms, right? So maybe we say public transform starting position. Interfaces can't have fields, of course. Of course, why wouldn't they be able to? That reminds me. So what are we going to do here? We'll say reset starting position. Better yet, we'll call this reset to we don't need the public modifier obviously because this is an interface. If we make this void, that means we can actually call this okay. What other things might we find interesting about an IBaseCharacter interface? Well, we're going to need a update wounds. We're going to need no. The thing is like, why are you struggling with the interface? Well, it's been my experience that although interfaces are a really, really, really good idea, Unity code tends to want to fight you in a lot of instances. I don't know, Unity just kind of wants you to make tightly coupled code everywhere, which of course becomes a nightmare to test, especially as the game grows in complexity. And then people are wondering why the fuck it takes games so long to come out or to ever reach deadline. It's just like, holy shit, the architecture of these games is just riddled with errors. And it's not the engineer's fault per se, and it's not necessarily the product owner and manager's fault per se. It's, you know, everyone has to take responsibility for it from the top to the bottom. And you just engage in blameless engineering, just get everything out on the table, say, okay, here's all of the weaknesses in the architecture, all the unplanned features of our architecture, and all the ones that we tried to plan. And here's how we're going to do some strategic refactoring. And so I want my interfaces to be as lightweight as they can possibly be. You know, the less code that we have to write, that means that's less code that we have to maintain, which means that's less opportunities for us to create bugs or run into corner cases in our code where bugs are exposed, which you'll definitely want to find those anyway, but one step at a time. Oh, that's me drinking my latte, finishing it up. A lot of programming is sitting around looking at a few lines of code and thinking about all of the options and all the rabbit holes it's going to drag you down and waste your time. So here's what I'm thinking. Update wounds. Where's that coming from? Well, I've been thinking a lot about wargaming rules lately. And I think really there's only really a handful of attributes that I'm concerned about with a character. I want wounds, which are basically like hit points or the health bar of a model. I want its armor. This is gonna be a modifier that somehow applied to its defense, right? When doing saves against attacks. Speed, which is a movement, is measured in whatever distance units are being used by the game. Could be inches, millimeters, miles, feet. What doesn't matter. There's a melee modifier applied to close combat, a shooting modifier applied to range combat, and a special modifier applied to abilities, whether those be magic or however you want to conceive them as fits the flavor of your particular faction. And, what I kind of envision is this quote-unquote universal wargame engine is being able to live as a web service and be able to simulate all sorts of battles using the rules that we're going to bake into it. And I think it's going to be fun. And we're going to be able to generate. See, one of the end goals, wink, wink, nudge, nudge, is to start bolting on our super secret AI that you don't know we've been developing, and have that generate new wargaming scenarios from our rules engine. New rules for engagement, new base mechanics, new attributes, new turn structures, new like command hierarchies, everything. So, but for now, let's just see if we can get a few things implemented, and let's see if we can live up to our grand designs and our big gigantic plans. Where are we at right now? Okay. So, although we have those attributes, we know we're going to be exposing them as fields and not as properties, and we can't have fields on our interface. So is there anything else on the interface that we think we're going to need? We can probably actually take this off for now. Um, oh yeah, we probably need a death sequence. We're going to need a damage sequence. See, now we're thinking. We just need some inspiration. And now we have to think about, here's an interesting philosophical question for us. Do we want our abilities to be on as a stack or as a heap, right? Do we want last in, first out, like a stack? You know, you push things to a stack, and then whatever's on top, you pop that off first, and you work your way back down. Or do we want to have a heap, where it's kind of more like contiguous, first in, first out effects processing? I kind of like the stack. Let's see if we can find a useful .NET stack data type. Yeah, we definitely do have stacks. It's in, oh yeah, it's real easy. So, oh, we already have system collection. System collection is not generic. So, let's do a stack of, we're going to say game object for now. Let's see. We call these modifiers. I think we need to do a get and probably a set. Cool. So if we go to our stack type and we hit F12 on our keyboard on Windows, we can come over here and take a look at kind of what this class looks like. It implements the IEnumerable, iCollection, and IEnumerable generic interfaces. And we can initialize it. We have 3 constructors available to us. We can do a parameterless constructor, which is good. We can pass in an integer to determine the capacity, and we can also pass in a collection, and the stack will be as big as the collection that we pass in. So anything that implements IEnumerable can be passed in here. Maybe in a list or an array. Who knows? You know, anything that implements IEnumerable. I don't have any implementations yet. So, another thing here, we can peek. So we can do all sorts of interesting things here with our stack. We can see if it contains an item, which is good. That means we can do what should be non-destructive, non-mutating peeking of it. You know, we can see if it contains it. We have a peek method, which should be non-destructive, should have no side effects. We have pushing and popping, which is what we would expect. We're going to push it to the stack. We're going to pop one off the stack, right? And we have toArray, which is very interesting. We like having arrays of things. We like to be able to, loop through them, iterate through them. So that's pretty useful that we can get an array out of here built into the interface. And we also have an enumerator, so which is very interesting because we may be able to, since it has an enumerable or an enumerator, we may be able to put IEnumerable. We may be able to implement IEnumerable and do the oh man, what are those called in Unity? Coroutines. So maybe we might be able to do some pretty easy coroutines, which basically means we can implement our stack in a non-blocking way, which means we can have other events and other meters ticking and running and spinning without having to lock around our stack. So that could be useful too. So we'll just see what happens. But anyway, for now, we're just concerned about modifiers. And yeah, I think I tend to like modifiers applied this way, last in, first out. So death sequence, damage sequence. I guess we probably need a health sequence too, or a we need a hit sequence, definitely. It's a sequence of events that's going to happen when we hit something. And let's see. Is oh yeah, maybe we have has line of sight. This will be important. We actually want to make this a Boolean. It's very important that we have line of sight. If we don't have line of sight, then we shouldn't be able to do anything. Okay. Oh yeah, then we need a melee attack. We want a shoot attack. We want all right, I think that's about it. So let's review what we kind of think we might maybe need to describe a basic contract for our character. We want a stack of game objects. These are going to be the modifiers. Okay. We can implement that as an array, right? Yeah, and then we can either just pop it in as is or reverse it and pop it in whatever we need to get the stack the way we want it to be. And okay, so we can maybe let's make a note here. Have backing okay. We're gonna need expose a transform as the starting position. Okay. Line of sight is going to be hard because we're going to have to do some line array tracing. To determine if obstacle is between two models and or units. That's going to be fun. That's going to be a fun algorithm to think about, huh? Okay. And why don't we go ahead and clean this up a bit. Move the unnecessary using statements. Okay, we have our base character. Let's implement this thing. Oh, Visual Studio, a bit easier to do this in Unity. No, don't initialize templates. I don't need a template, goddammit. Alright, I'm just going to call... Can you see this? No, you can't even see my dialog window that I have here. It's torturing me. We're just going to call this BaseCharacter. I bet you the namespace is going to be all weird. Yep. You guys suck. That's not what I want, dude. Don't put the namespace like assets. Fortunately, namespaces are not strictly tied to the folder structure in C#, which this will probably drive some purists crazy. So we're going to have what? MonoBehaviour. We're going to need to import Unity Engine. And we're also going to need what? IBaseCharacter. And let's implement that interface. All right. Fantastic. This is fantastic, Mr. Bombastic. I don't know why I'm thinking about that song. Anyway, let's see what we have here. Not too shaggy. Yeah, I went there. That's right, I said it. I made a dad joke. What are you going to do about it, huh? Hey. Yeah, Link is powerful, but we don't need it right now. Let's see. Make a region again. We'll call these the fields. Why not? We'll go back and tidy up our code some more a little bit later. So let's call this public. Oh, now we want game object. We'll call this. How do we do our DiceRoller? What's the convention? Okay, very good. I'm going to call this modifiers with a capital or lowercase. All right. We don't want it to be null, okay? There, we don't want it to be null. We want to avoid null pointer exceptions, right? And has. We're just going to assume true. Yeah, why not? You know what? I think what we're going to do here. Watch this. Oh yeah. So then we can model our special abilities as just regular game objects that have their own game object life cycles, right? So now we could just do can we just do new stack game object modifiers. Is that legal? That's legal. And we don't want a set, right? Why don't we do privates? Yeah, we want to gate this. We don't want anybody to be able to add modifiers. There's probably going to be rules about whether or not we can add modifiers. So we're going to have private set. Yeah, I think this is good. Like, well, except for this. Oh, it's got to be public. All right, whatever. Set. So we're going to say, what do we say? This dot modifiers equals stack game object equals value dot to array. Wow. So that way the stack is, I mean, you can get it, but so what this means is that, you know, once I set the modifiers, right, or if I get the modifiers, I can set the stack. Basically, we want the underlying array of the modifiers. But every time we get it, we just basically want to build a new stack in memory and load up the modifiers from the array. And that way we can, repeatedly use these over and over again. So, uh, yeah. Okay. So now why don't we go back over to Unity for a second. Let's compile this in here. You see, can you see it in the video? Down there at the bottom? This is this is that new C# syntax I was talking about. It doesn't like our arrow expression to use as the getter. So why don't we go back into Visual Studio and we'll downgrade our code. Okay. We'll turn this into there we go. Go back over to Unity. Should be fine now, right? Yeah, okay. Let's get a character on the, let's just take this, put it on here. Come on now. Alright, well, we'll make a new game object. We call this our base character. I expect we're going to be cloning this a lot. We're going to make it static too. So we only want one of these, right? So let's do base character. Okay. There we go. Now let's go over to our prefabs and let's make a base character prefab. And we're going to go ahead and save this. So now we're doing a work in progress. You probably can't see this because OBS doesn't show you my pop-ups. Only the main window is being captured. I got to fix that somehow. I'll have to ask some kind of streaming guru. Anyway, first iteration of the base character. Okay. Okay, we're a little over an hour here. Got a lot of great stuff done. Just to recap, let's switch back over to Visual Studio. We've created a base character that implements an IBaseCharacter interface. It's also a game object. It's got modifiers and special abilities and line of sight. Modifiers get popped off as a stack, and since it's a base character, we want to throw exceptions when this is actually going to be fine. Nobody should actually be using a base character directly. This should just be something that people, inherit from and then update and override for themselves. So we probably have to make some of these things virtual, which would be no problem. We can open up the class however we need to. So that's what we have. We have our base character, and we updated our dice roll a little bit, polished that up a little bit, and basically we added target checking, and we crossed that off our to-do list. We'll implement reroll checks at our next time. But I wanted to get away from the dice roller and work on the character a bit. Okay, so that's it. Just a quick shout out to the business side of things. Thank you so much to everyone who's checking out these videos. You can support us directly on Patreon at patreon.com/officialraylong. The link will be down below. You can also check us out on Teachable for free courses on how to think like a programmer. Basically, if you want to know how I went from idea in my head to the code that you've seen us develop today, you should definitely start looking at the free course that I offer on the link below the video at full-stack-distributed-systems.teachable.com. And also on Twitter, follow me at officialraylong. Alright, thank you so much for your time. Thanks for checking out this video, and I will talk to you all later. Bye for now.